Good morning, Algebra 1 students. We are now going to try to explain the intervals of increasing, decreasing, and constant. So first we're looking at this and notice that there's 5 sections, but unfortunately I have 6 on here, so we're going to take that one off. We're not going to be using that one. So section 1, if you'll notice, as I'm moving my pencil from left to right on the function, it's going down. Since it's going down, that means it is decreasing. Okay, if it were going up, it would be increasing. If it wasn't changing, if it was staying at the same height the whole time, we would say it was constant. So section 1 is decreasing between the x values of, well, wherever that is to here. And wherever that is, looks like it's been decreasing for a long time because it's coming from all the way to the left. All the way to the left is negative infinity. And in fact, over here is all the way to the right. So that's infinity. That's a positive infinity. So we're saying it's decreasing between the x values of negative infinity and right here. And that x value would be negative 5, negative 6, negative 7. So we're going to say that it's decreasing between the x values of negative infinity and negative 7. So in interval notation, we put the left one on the left, the right one on the right. And we know that this is always going to be a parentheses because we can't contain infinities. But this is also a parenthesis, and this is why. And this is a little complicated explanation, but right when I get to this point, it's no longer decreasing, and it hasn't started increasing yet. So it's not included in the decreasing part, and it's not included in the increasing part. So that's why we'll always end an interval for increasing, decreasing, or constant with parentheses. Now that makes it a little easier because you don't ever have to think about where the brackets go, because they don't go on increasing, decreasing, and constant intervals. So now on section 2, it looks like it's going up from left to right, so we would call that increasing. And we already know that it starts right at negative 7 on the x values, but it stops right here, which that looks like negative 4 to me. So it's increasing between the x values of negative 7 and negative 4, and we know we get parentheses on both ends. Section 3, on the other hand, it's going down again, and it stops going down when I get to here. That's at negative 1 on the x-axis. Now, a common misconception is to make the break where it starts to become a negative function, but we're not talking about that. We're talking about increasing, decreasing, and constant. And it's still decreasing at that point, so we don't stop until we get to the not decreasing part, which happens right there where the x value is negative 1. So that is again decreasing between the x values of negative 1 and about, oh no, not negative 1, negative 4 and negative 1. Okay. And then at this point, the function's not going up and it's not going down. So because it's staying the same the whole time, we say it is constant. So the function is constant between the x values of negative 1. We knew that was going to happen because it's a handoff there. And stops being constant there where it starts to do something else. And that's at the x value of 3. So it's between negative 1 and 3. And now it looks like it starts to go up again. That makes it what? That's right, it's increasing between the x values of 3, and it just looks like it keeps going, doesn't it? So between 3 and infinity, it keeps on increasing as we go that way. So yeah, so we're going to write 3 to infinity. And we don't say infinity and beyond because that's kind of a silly thing. You can't get beyond infinity. So the whole Buzz Lightyear thing is just a dramatic thing. It's supposed